Welcome to episode 18 of .NET Concept of the Week, where I explain a concept related to .NET programming every week in a short video. Now I know I was gone for a long time, but I decided to restart this format, so expect more videos in the future. In this longer episode we are going to talk about DiagnosticSource. I will explain you what that is and I will show you how you can use it. Additionally, we will also talk about the Activity class a little bit. Now these are useful tools if you want to have visibility into your code in a production environment. So if you plan to implement tracing or observability for your .NET applications, then keep watching. DiagnosticSource is a simple module that helps .NET developers to instrument their code for production time logging with rich data payloads. These logs can be typically consumed within the process that was instrumented. So DiagnosticSource itself has basically two capabilities. You can write events to it, and on the other end you can listen for events and do something with the data. So it's like a trace or a log, but logs are typically just strings, but DiagnosticSource works with objects, so it is structured data. Therefore, you can do a little bit more with it. For example, you can create metrics based on it or use the information for building observability into your system. Now this probably sounds very theoretical, so let's jump to Visual Studio and see what all this means in practice. So DiagnosticSource has two sides. There are components that send DiagnosticSource data and there are listeners that can receive the data. Let's start with the first one. To keep it simple, we have a dummy library that generates a random number. As always, I keep the code minimal here. We don't even bother to host this class in a separate project. We just simply have a .cs file for it. You can imagine a real library here. For example, this library could be ASP.NET Core itself or the system.net.http client type to create HTTP requests or something similar. Now let's instrument this library with DiagnosticSource. The first thing we need is an instance of the DiagnosticSource itself. This is going to be a private static read-only field. It's recommended to make this private static. In case it would not be a static instance, it would mean that you would be able to attach multiple receivers to multiple instances of this DiagnosticSource, and that would lead to all sorts of problems like putting pressure on the GC, missing some events, and creating thread safety issues. We pass the name of the class to the constructor, and then a receiver can register to this DiagnosticSource instance based on this name. So we have a DiagnosticSource instance that can send stuff to a receiver. The main part of this logging architecture is the diagnostic listener class, which receives the events. The DiagnosticSource type is just an abstract base class that defines the methods needed to actually log the events. The diagnostic listener holds the actual implementation. Now let's start using this instance. In our dummy method, we are going to send two traces. The first one will notify the listener that the method was entered, and the second one will notify the listener that the random number was generated, and it will also tell the listener what the generated random number is. In case of a real-world application, you can think of events like an HTTP request was started as the first event, and then the second event would be about the response to the request with the HTTP status code and things like that. Or the first one could be from Entity Framework Core with the SQL statement, and the second one could be about the finished database call with the response. So let's send a very simple event. For this, we can call the write method on the DiagnosticSource instance. The first parameter is the key of the event. In this case, I simply use the name of the class and I append start generate random to it. The second parameter is the payload itself that we want to send to the receiver. As you can see, this is an object, so we can pass anything we want into this, and the listener side must use reflection or cast this instance in order to access the properties or fields on the payload we pass here. In this case, we don't want to send any payload, so we simply send null. We will use this parameter in the next trace we send. So we send this when we enter the method, then we generate a random number here, and then before we return this number from the method, we write another trace. This time the key is the class name plus dot and generate random. And then I create an anonymous type here, which is going to be the payload. In this case, we could simply pass the integer value as the parameter, but with this anonymous type, I would like to show you what typically happens in a library when they are instrumented with DiagnosticSource. Most libraries simply create similar anonymous types and just put everything they want to send as properties onto this type. Later we will see how the receiver deals with this. Now there is one important missing thing here that you also should do when you instrument your code. We wrap both calls into an if block and we only execute them when there is at least one active listener. This can be checked by the isEnable method. We simply pass the name of the source to this method and it will tell us whether someone is actively listening to it. As you can see, we named our diagnostic source here and we use the same name when we check for active listeners. This is especially important because in production code, which is potentially called million times in a second, you only want to execute the method call when there is an active listener. Furthermore, there is also an allocation here. Typically, we allocate an object when we create the payload, so doing that only makes sense when there is an active listener. And with this, we are done. So here is how you instrument your code with diagnostic source. In this case, we send a start event and an end event with a parameter. Of course, a real-world library or application could have more events, but basically you see the main things here: a static read-only diagnostic source instance, the isEnabled call to make sure that there is an active listener, and the write call to emit the diagnostic source traces. Just as a side note, in case you already saw some code instrumented with diagnostic source and you saw that it is done by using a so-called activity, then just wait and we will come back to that later in this video. For now, as a first step, let's just focus on diagnostic source. So the instrumentation is done. Now let's move on to the other part and let's see how you can register receivers. Let's do this in a method that we call subscribe. For this, we will need two classes. The first one is going to be the one that subscribes to a particular diagnostic source. This class implements iObservable diagnostic listener. We have three methods here. We will focus on the onNext method. Now the second class will be the one that will receive the events that we just emitted in the mySample library. This time we implement iObservable key value pair string object. Remember, these diagnostic source events are key value pairs where the string is the key and the object is the payload. So we will receive our events in the onNext method of the myLibrary listener. Now before we implement this, let's first hook up the whole thing in the subscribe method. Diagnostic source is out of the box referenced in every .NET Core application, so we have access to the diagnostic listener class here, and on this class we have access to the allListeners property, which has a subscribe method. We pass a new subscriber instance into this method. With this, for every single diagnostic listener that is present in this application, in the subscriber we will receive an event here in the onNext method. Let me show this to you. We already generated a random number here, so I simply put a breakpoint here and start the application. As you can see, the diagnostic listener that we created in the mySample library class is reported here. Now let's subscribe to this. For this, we simply add an if statement here, and in case the name of the listener is equal to our listener's name, we simply subscribe to it by using a myLibrary listener instance. Similarly, let's put a breakpoint here in the onNext method of the myLibrary listener, and as you can see, first we receive the start event. Now I hit F10 and then we receive the end event. And we also have a payload in this case, and this contains the random number. Let's also see how such a receiver typically looks like. Remember, now we are on the other side of the system. Now we are implementing the components that do something with the diagnostics data. I simply create a switch case statement on the key of the received event. We will have two cases here, one for the start event and one for the end event. For the start event, there is no payload, so we just print generate random started. In case of the end event, we can do more. For example, we can also read the payload, and for this, I will use reflection here. So with getType.getTypeInfo, I have access to the type info of the payload, and then by calling getDeclared property and passing the name of the property, I will get the property info of our property that stores the random number, and then by simply with getValue, we read the value itself. Then similarly to the previous case, we just use console.writeLine to print the event with the payload. So let's see this in action. I start the application, and as you can see, our diagnostic source events are printed to the console. Now in itself, this is not very useful, but probably you can imagine that this opens up a whole bunch of opportunities. For example, we could measure the time between the two events, and with that we will know how long the operation took. In case of the generation of a random number, this isn't necessarily useful, but if this is, let's say, an HTTP request to a downstream service or a database call, then with this you will immediately know how long it takes to serve those given requests. But let's not go there yet. I will show you how you can do more than just console.writeLine with this data in a next video. Let's just focus on DiagnosticSource itself this time. Alright, so I keep telling you that frameworks and libraries by Microsoft also emit these DiagnosticSource events. Let's see this in action. For this, I simply create an HTTP GET request with HTTP client to my own website. Additionally, I add the breakpoint to the onNext method in the subscriber. In the first run, we get our own diagnostic listener from the MySample library. We already saw this. Now let's continue. This time we received an HTTP handler diagnostic listener. This is the listener that emits diagnostic information from HTTP client. So let's do two things. Let's create a second if statement to check for HTTP handler diagnostic listener where we also subscribe to it. And let's also create an observer that will receive the events. Similarly to the previous one, we will simply receive events from it in the onNext method. Now let's set a breakpoint in the onNext method and see what kinds of events we get. First, we get an event with the key system.net.http request out.start, and the payload is the HTTP request message object itself stored in the request property. On this object, we have a whole bunch of information about the request. We have the URL here, we have the HTTP method, so we also see that this is an HTTP GET and all sorts of other things. Let's continue. Now we have a system.net.http.request event, and then we have a system.net.http request out.stop event. This time we have both the request and the response here, which means we have direct access to the HTTP response message object. So for example, we see that we got an HTTP 200 back from my website. If we continue, there is another system.net.http response message here. So what we just discovered is that we get events when the HTTP request starts, and we get events when the HTTP request ends. There are two pairs of events, which in this case has some historical reasons. The system.net.http request and the system.net.http response events are deprecated, and according to some GitHub issues, those will be removed in future versions, so we can simply ignore those. Those two are the ones that do not use Activity. We will see later that the .start and the .stop postfixes are generated by Activity. To get this short, I simply paste a couple of lines of code here. Similarly to our previous example, with reflection, we read and cast the properties to their types, and then we use console.writeLine to print things to the console. Additionally, we also measure the time between the start and the stop event. This code is of course not production ready. We don't really have serious error handling here, and for example, there is also an event for exceptions during the HTTP call, which we completely ignore here. So this is just to give you an idea about what you can do with this. And as you can see, this time when we start the program and take a look at the console, we also see a whole bunch of information about the HTTP request, and we even see how long the request took. So this was an example on how you can get diagnostic information about HTTP client, and like I said before, there are plenty of other libraries that generate similar events. For example, ASP.NET Core generates events for every incoming HTTP request. Also, MVC gives you a whole bunch of information around routing, which controller is executed, and which action method is running. Similarly, Entity Framework Core also tells you when a database request starts or ends, and there are also a whole bunch of other libraries using it. Now, before we end this, there is one more thing I would like to talk about, which is the Activity class. Activity is a class that enables storing and accessing diagnostic context and consuming it with a logging system. And even better, it is integrated with DiagnosticSource. In fact, the way we instrumented our library with DiagnosticSource previously is the old school way of doing it. Most libraries use DiagnosticSource in combination with Activity. So basically, Activity is an extra layer on top of DiagnosticSource with some additional features. Every activity has an ID, and activities can be hierarchical, so an activity can have child activities, and in case an activity is not a root activity, it also has a parent ID. Additionally, there are two useful properties on the activity class. It has a tags property, which is basically a set of key value pairs which represent context needed for logging. Tags are stored on a given activity and they won't be propagated. The baggage property is also a set of key value pairs, but those are passed to child activities. This means that the information added to the baggage property can leave the process, so be careful about this one. Here's how this looks in code. First we create an activity called myActivity, then we start the activity. With this an ID will be created and additionally a diagnostic source event will be raised. Then typically in a real-world application or class library, you will have some logic that you would like to track with your activity. Then the next two lines show how to add an item to the baggage and the tag properties. Again, tags are local to the activity. You can access and change those anytime you have access to this given activity. Baggage is something that is propagated to child activities, so you can access that information both on this activity and on all its children. Then here is how you can access the ID and the parent ID of the activity. And in this last line we stop the activity, and this will again raise a diagnostic source event. There is one last super important property, which is the Activity.Current static property. Activity.Current points to the currently active activity, which flows with async calls and is available during the request processing. This means that the start activity method sets the given activity to the current activity, and with this property you will be able to access this current activity at any point in the code, and then DiagnosticSource.stop activity will clear it. One cool use case is, for example, using it in the onNext method on the listener side, as you can see it here on the slide. So everything you put into the tag and baggage properties is of course available to components that listen to your diagnostic source events. Now let's jump into Visual Studio and write some code using the activity class. So we have this doThingAsync method here, and this is where we are going to use the activity class. Remember, in the getRandomNumber example previously, we only used diagnostic source. This time we will also use activity. The method doesn't really do anything except it creates an HTTP request to localhost 5000/values, but let's imagine that this is something useful that you would like to trace. So let's create an activity and let's call it doThingAsync. As the first step, we start the activity. We already have a diagnostic source instance here, so I simply reuse that one. Similarly to the previous example, we wrap this to the isEnable method. Otherwise, we would unnecessarily call the method here and allocate an object also in cases when there are no listeners listening to these events. So this line will fire up an event called doThingAsync.start, but additionally, it will also start the activity, so it will create its ID and it will also set it as the current activity. Let's also use the text and baggage properties. For this, I will add one dummy value to each. Again, imagine that in a real-world tracing scenario, you would add something here that is relevant for tracing. And then before the method ends, we stop the activity. This will trigger a diagnostic source event with doThingAsync.stop, and it will also clear the current activity. Now let's use the instrumentation that we created here. We already have our myLibrary listener, and since we reused the diagnostic source from our previous example, we can also reuse this class to receive the new events. So all I do is that I add two other cases here, one for the start event and one for the stop event. In the start event, I print the ID of the current activity. Then in the stop event, let's iterate through the text here and print them. Now I start the application, and as you can see, here we have the ID of the activity printed in the doThingAsync.start event, and this is the value from the text property. So as you can see, we set the current activity here in the doAsync method by just starting the activity, and we access it through the Activity.Current property in our myLibrary listener. To show how powerful this is, let's also do one other thing. We are here in the listener that listens to all outgoing HTTP calls, and remember, in the doThingAsync method we have an outgoing HTTP call, so this onNext method will fire. Let's also add another console.writeLine here, and let's print the current activity ID. We do this both in the start and the stop event. By the way, as you can see, the HTTP client class also emits events with keys that end with start and stop. This means that HTTP client internally also uses the activity class, so the name of these keys is not a coincidence. Anyways, so let's start this, and if we take a look at the output, we can see that the activity ID is the same, so we can correlate all these events. We know exactly that this HTTP call happens in the same transaction as this doThingAsync.start call because both have the same activity ID. Obviously, in this small example, it's not a surprise, but in a big production application, this is very, very useful. Now let's go a little bit further. There is this HTTP call that we haven't really talked about. This is a tiny ASP.NET Core application that basically just responds to the call. Keep in mind this is here a different process and it could run on a totally different machine. So we have one console application here. That's where all the code we saw previously is running. And then we have this ASP.NET Core process. Now in the console application, we create an activity before we call out into this ASP.NET Core process. So let's access the Activity.Current in the ASP.NET Core project. In case it's not null, let's print the items from the baggage. Remember, the baggage is passed to child activities, and let's also print the current and the parent activity ID. Alright, now I'm going to start both processes, and we are going to look at the console output. So here we have the baggage value in the ASP.NET Core application, and remember, we added this value in the console application to the original activity. And even better, we see the ID of the newly created activity, and we see that its parent ID is the ID of the activity that we created in the console application. So this is a super powerful feature of the activity class in action. If you have multiple services communicating to each other through HTTP, then activity makes sure that the IDs are set properly, so you can correlate the activities across services and you will be able to trace through a whole transaction. In this case, we know that this tothing async.start started the whole thing, then it created an HTTP request which ended with a status called OK. We also see the duration of it, and on the callee side, we also see additional information about this request which we can find based on the parent ID. So this was activity in action. Obviously, a real-world application has more useful code. This was mainly dummy code, but hopefully this gives you the knowledge to work with this stuff in production code. Alright, so let's summarize what we learned in this video. We saw how diagnostic listener works, we instrumented a small library, we also generated a receiver which prints out those diagnostic source events to the console. We also saw that libraries from Microsoft are out of the box instrumented by diagnostic source, and we can have all sorts of diagnostic information for those libraries by writing a couple of lines of code. And then finally, we saw that you can use the activity class to propagate tracing information between components. In case of the baggage field, these components can even be in different processes. The activity class makes sure that those information flows through activities. Now in this video, we basically only use console.writeLine to see these events, which is clearly not that useful. So we stop here, but there will be a second part of this topic, and I will show you how you can store and visualize these events with more powerful tools. Alright, as always, the source code and a whole bunch of related resources are linked in the video description. I hope you found this useful. If you liked the video, please hit the thumbs up button and subscribe to the channel. Thanks for watching, and next week I will explain another .NET concept.